welcome to True Projects. In this video, we are going to explain about a project titled Multi-Cancer Detection Using Machine Learning and Deep Learning. In this project, we discuss about various different cancers and the prediction. Cancer remains a formidable global health challenge, and our innovative approach aims to revolutionize the early diagnosis and the treatment. Combining the power of artificial intelligence with a vast data set encompassing the breast, kidney, lung, and pancreatic cancer, our mission is to enable the precise and timely detection leading to the improved patient outcome. With the state of models like of logistic regression, SPM, decision tree, and many of, we strive to unlock the hidden pattern and the correlation, offering the unprecedented insight into the cancer detection. The primary objective of our project is to develop an advanced multi-cancer detection system using ML and DL, targeting the breast, kidney, lung, and the pancreatic cancer. We aim to leverage the vast potential of AI and large-scale data sets to achieve the early and accurate cancer identification. By employing the models such as logistic regression, SPM, decision tree, and the neural network, we enhance the diagnostic precision and the efficiency through the timely detection, and our project aims to improve the patient outcome by enabling the personalized treatment plan and the intervention. We aspire to contribute to the reduction of the cancer-related mortality rate and empower the healthcare professionals with a powerful tool for the informed decision making. And these are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7, Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3, RAM of minimum 4 GB and hard disk of minimum 250 GB. Project, these are the steps we need to discuss. The first one is importing the libraries, and this we need to import the necessary Python libraries like NumPy, Pandas, Matplotlib, sklearn to handle the data manipulation, visualization and the machine learning model. And the second one is importing the dataset. We need to import and load the datasets of breast, kidney, lung and the pancreatic cancer, which should contain the relevant features and the target labels for each cancer type. And the third one is data visualization. We need to perform the exploratory data analysis to gain the insight into the dataset and understand the visualization and the distribution of the data. Visualize the data using the plot and the graph to identify the pattern, correlation, and the potential outliers. And the next step is model building. Here, we are building the model by of different algorithms, and for the breast cancer, we are building of different algorithms like the first one is decision tree. Constructing a decision tree model for the breast cancer based on the feature split to make the prediction. And the second one is logistic regression. Logistic regression is a supervised machine learning algorithm. It is used to predict the probability of the breast cancer occurrence within it. And the next one is k-nearest classifier. K-nearest classifier is also an supervised learning algorithm which is used to employ the k-nearest neighbors to classify the cancer cases based on the similarity data points of the K. And the next one is ANN. ANN stands for Artificial Neural Network, and where it creates a neural network with the hidden layers to learn the complex relationship within the breast cancer data. And the next one is SPM. SPM stands for Support Vector Mission. Support Vector Mission is used to classify the cancer cases into the different classes based on the hyperplan separation. It is most efficient supervised algorithm. And the next one is bagging. Bagging is also a technique like of bootstrap aggregating for combining the multiple decision trees for the more robust prediction. And the next one is random forest. Random forest is also an ensemble technique that will use the random forest for improved classification accuracy. And the next one is voting classifier. Voting classifier is an ensemble technique where it combines the prediction of the different multiple models by using the majority voting or the average voting. And the next one is Adabus classifier. Adabus classifier is used to create a strong classifier from the weak learners of the breast cancer dataset. And the next one is lung cancer. Lung cancer is used for the binary classification that estimates the probability of the lung cancer occurrence based on the input features. And here the first one is logistic regression. Here where it takes the binary classification and it is also an supervised learning algorithm that estimates the probability of the lung cancer that occurrence based on the input features. And the second one is k-nearest classifier, a simple non-parametric algorithm that will use it to classify the lung cancer cases by the majority class among its k-nearest neighbor in the feature space. And the next one is support vector mission, also known as SVM, is a powerful classifier of and separates the lung cancer cases by finding the optimal hyperplane in the high dimensional feature space. And the next one is decision tree classifier. Decision tree classifier is a tree-based model that uses the feature split to classify the lung cancer cases by recursively partitioning the data. And the next one is naive-Bayes. Naive-Bayes is a probabilistic classifier based on the Bayes theorem, assuming the independence between the features that are suitable for the test and the categorical data. And the next one is random forest. Random forest is an ensemble method that builds the multiple decision tree and combine the prediction to achieve the high accuracy and reduce the overfitting. And the next one is stacking classifier, a meta-learning algorithm that combines the prediction from the multiple models to create a new model, improving the overall performance. And the next one is voting classifier. It is an ensemble algorithm where it combines the prediction of multiple classifiers through the majority voting or the average voting, resulting in the more robust and the accurate classifier. And the next one is of kidney cancer. Here we used these two algorithms. That first one is Inception ResNet V2. Inception ResNet V2 is a deep convolutional neural network architecture designed for the image classification, where here we need to upload an image that related to the kidney and that will classify whether that image containing or detecting the kidney cancer or not. And the next one is DenseNet. DenseNet is also a deep convolutional neural network where each connects each layer to the every other layer in the feed-forward fashion, promoting the feature reuse and interconnected with the neurons within it. And the next one is pancreatic cancer. Pancreatic cancer, we use different algorithms, and the first one is logistic regression. Logistic regression is a linear model and mainly it uses for the binary classification, here whether it predicting the likelihood of the person having the pancreatic cancer or not based on the input feature. And the next one is KNN. KNN means of K nearest neighbor algorithm classifies the pancreatic cancer cases by considering the majority class among its K nearest neighbor in the feature space. And the next one is SVM. SVM is a support vector mission, a classifier that separates the pancreatic cancer cases by finding the optimal hyperplane in the high dimensional feature space. And the next one is decision tree. Decision tree is a supervised learning algorithm and a tree-based model which is used to predict the pancreatic case by recursively partitioning the data based on the feature split. And the next one is naive-Bayes. Naive-Bayes is a probabilistic classifier based on the Bayes theorem, assuming the independence between the features that are suitable for the test and the categorical data. And the next one is random forest. It is an ensemble model that builds the multiple decision tree and combines the prediction to achieve the high accuracy and reduce the overfitting. And the next one is AdaBoost. AdaBoost is a boosting algorithm that creates a strong classifier by combining the weak classifiers that of multiple ones. And the next one is stacking classifier. Stacking classifier is a meta-learning algorithm that combines the prediction from the multiple models to create a new model that improves the performance of the model. Voting classifier. It combines the prediction of multiple classifiers through the majority voting or the average voting, resulting in a more robust and accurate classifier. And it is also one of the ensemble technique, where each model listed as offers a unique approach for the cancer detection, leveraging the various techniques and the algorithms to achieve the accurate prediction. The selection of this model depends on the characteristic of the dataset that we use it. And the next step is training the model. Here we need to first split the dataset into the training and the testing set and train each model using the respective training data for the specific type of cancer. And the next one is user gives the input. Here we are using the Flask as a web interface to provide the input to the application and the process the input to match the format to. The given input is pre-processed per prediction. Here in this stage we need to pre-process the user input data to match the format that is used during the training. And the next step is trained model is used for the prediction. Using the pre-processed user input data to make the prediction to the corresponding trained model for the specific cancer type. And the last one is final outcome is displayed. Displaying the predicted result indicating the likelihood of the class of cancer that is of present or not or type for the given user input. And the next one is the execution of the project. To execute the project first we need to open the code folder. And this is dataset folder containing of the dataset that we used, and the sample folder containing of images that we used for the testing the performance of the model, and the static folder containing of the folders like CSS, images, JavaScript, uploads and web fonts within it, and the template folder containing of the HTML documents typically include of hello, home, index, result sign in and sign up pages within it, and the app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handle the server-side operation such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the breast, kidney, lung cancer or these are the IPYNB file which contain the information or the combination of the code, graph and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the model files are contain the information related to the algorithm and is loaded into the project code during the various tasks and such as making the prediction on the new data performing the specific operation. Signup.db is a database file that will be used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command cd space and paste this code folder path. By this it will change the current directory to the code folder path, and then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or the logical issues. And then click on the enter button. After running this app.py file, the Flask framework will host the application locally at the default address. Like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. Here we can see that this is the title of the project and containing of the sign in and the sign up buttons and related information about it. And we need to click on the sign up button, and here it will redirect it to the sign up page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here we redirected to the sign in page containing of username and password to be entered as of admin. And then click on the sign in button. Here it will redirect it to this page containing of the breast cancer, and we need to fill those details of mean radius as of 17.9 and the mean texture of 21.25 and the mean parameter is of 122.25 and the mean area of 1001 and the mean smoothness is of 0.0132, and then click on the submit button. Here it predicted as of you are safe, and in this way we can enter the other details too. I'm entering other details of like 13.54, mean texture of 14.36 and the mean parameter of 87.46 and the mean area of 566.63 and the mean smoothness of 0.09779, and then click on the submit button. Here it predicted you have a chance of having the breast cancer. In this way we can predict it, and by clicking on the pancreatic cancer button, here it will redirect it to this pancreatic cancer, and here we need to enter those details too. I'm entering the details as age 32 and the plasma rate is of 9 and the creatine is of 0.3845 and the LYE1 is of 0.01538816 and the REG1B is of 2.45 and the TFF1 is of 11.842 and the REG1A is of 1221, and then click on the submit button. Here it will redirect it to the result page and it giving you are safe, and here we can enter the other details too. I'm entering the detail as of age is 33 and plasma CA199 is 11.7 and the creatine is of 1.83222 and the LYVE1 is of 0.89329192 and the REG1B is of 52.99488 and the TFF1 is of 654.28217 and the REG1A is of 1262, and then click on the submit button. Here it predicted as you have a chance of having the pancreatic cancer, and by clicking on the home page, and here we can click on the lung cancer button. Here we redirected to this lung cancer images, and we need to enter the details of yellow fingers as 1 and the anxiety is of 1 and the peer pressure is of 1 and the chronic disease is of 1 and the fatigue is of 1, allergy is of 1, wheezing 1, alcohol consuming 1, coughing 1, swallowing difficulty 1, chest pain 1, and then click on the submit button. Here it will redirect it to you are safe, and here we need to enter the other details like of click on the home button and redirect it to this lung cancer. I'm entering the details of yellow fingers 2, anxiety 1, peer pressure 2, and the chronic disease of 2, and the fatigue is of 2, and the allergy is of 1, and the wheezing is of 2, alcohol consuming is of 2, and the coughing is of 2, and the swallowing difficulty is of 2, and chest pain is of 1. And then click on the submit button. Here it predicted as you are having the lung cancer, and we also having the other type of cancer, that is of kidney cancer. Here we need to upload an image. By uploading an image, it will predict whether the person is having the kidney cancer or not. And we click on the choose file button, and we need to select the one file, and then click on the upload button, and then click on the upload button. Here it will predicted as the image content of the tumor. And by using the try again button, here we redirected to this page, and by clicking on the choose file button and selecting another one, and then click on open button, and then click on upload button, here I predicted result as normal. In this way we can predict the various type of lung, kidney, breast and pancreatic cancers too. And in conclusion, our multi-cancer prediction project utilizing the machine learning and deep learning has yielded the promising result. By harnessing the potential of AI, we demonstrated the feasibility of early and accurate identification of breast, kidney, lung and the pancreatic cancer. Our efforts signify a significant step toward and the fight against the cancer, paving the way for the improved patient outcome and the personalized treatment strategy. As we forge ahead, we envision a future where this technology becomes an integral part of the routine healthcare, transforming the cancer diagnosis and the management.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.